Maybe not yet. Okay, so another application problem. You purchase a brand new 4K television for $3,200. It depreciates at a value of $400 per year. Create a symbolic rule for V of t over t years. Not really anything fancy here as far as like we have to account for thousands or anything like that. So my base rate is 3,200. I depreciate 400 per year. So I'm going to have 3,200 minus 400 t, because that's how many years go by. And it's color-coded right there to see where those numbers are coming from. And I'm going to name it V of t because that's what the question's asking for. If it didn't, you can kind of name it whatever you want to, because again, functions are kind of just something that you might need to reference. Now find the horizontal and vertical intercept. This is a bit of a review from the last lecture, so yes, we've covered this before. But yes, this isn't explicitly new, but this form kind of makes it go through nice and easy almost every time. There isn't a whole lot of solving to go from there. My vertical intercept. Well, if I want to find it the proper way, what I would do is I would plug in 0 and for my t into the formula, and I would get that my intercept is 3,200. But again, that's not an intercept, that's a value. I need to have a point. But if you're sly about this and you see, oh, that's y equals mx plus b, you can look and see b is your y-intercept, and there's your answer right away. You don't have to go through this solving process. So if it's in slope-intercept form, one of the huge advantages is you know one of the intercepts. You don't have to go through this process. You could honestly have gone back to that symbolic notation, circled 3,200, and said, thanks for the 3 points. We'll also have said the answer as well. Horizontal intercept, we do have to go about solving for that. So as we've seen before, we set v of t equal to 0, solve for t, subtract 3,200 from both sides. I divide both sides by negative 400, and my answer is t is equal to 8, or if I want to write it as a point, it is 8, 0. So those are my two intercepts. So the horizontal, yes, you still have to go about solving, but as I mentioned, vertical you could find immediately. Now, from there, what we're going to do is instead of kind of banking on this idea of slope and building points from there, we can actually graph with just that information. We have our intercepts at 0, 3,200, and 8, 0. And so we can just go into graphing. I fill out my graph. I make sure I add titles. My years need to go up to 8, and my vertical intercept needs to go up to 3,200. Space at 500, 1,000, 1,500, 2,000, so on and so forth. And that's all I need. All I need to do is plot those 2 points. I'm going to put them on my graph right here. And as we mentioned kind of again towards the beginning of this entire unit, all you need is 2 points to make a line. Draw a line through those 2 points, and I have my graph. Now, to the context of what these vertical and horizontal intercepts means. We've had practice with these. We found them. It's important to understand what we're actually talking about. If we look back at the problem, let's actually pull that back. 1 sec. Looking at the problem, we know that we're talking about a brand new 4K television that started at 3,200 and depreciated to a value of 400 per year. Keep that in mind when we're going through this question. Okay, if we want to talk about our first intercept, we look at that vertical axis. We say my intercept is 0, 3,200. What that means is that at time 0, the cost of my TV is 3,200, or is another way to say it. We initially purchased the TV that was worth 3,200, maybe a little bit more common English. People don't really talk about 0 time in the real world very often. Next part. Second intercept, horizontal intercept 8, 0. 8 is my input, so that would be how many years. Y is my output, which means the cost would be 0. An easy way to say that is after 8 years, the TV will be worthless or worth 0 amount. Any way you want to say that it is equal to 0. Both of those answers will work. Yes, you could kind of slightly alter them, but that's the idea. You should be talking about an initial time, your TV or the value of your thing was this, and after a certain amount of time, the value of your thing would be 0 if it's the intercept. For this, I'm going to call it method 1. technically there isn't a method 1 and method 2 in math. There is 2 separate methods. I'm just going to call it method 1 for a reference point. And this is on that second side of that worksheet. Find the equation in the line that goes through 3, 10 and 6, 22. This feels like the last example. Granted, the last example was applied, but we had 2 points. We were asked to find a symbolic rule or an equation. What we're going to do, and what we did in that first question, is start things off at find slope. I'm going to use that formula, y2 minus y1 over x2 minus x1. I'm going to make my y2 minus y1 22 minus 10 over 6 minus 3. That leaves me with 12 over 3. And again, that'd be valuable if I was plotting, but if I want to go about building a rule, I'm going to look for the solid number, which in this case is 4. Now, I want to find my intercept. And again, we could go through this process of finding the change over a certain amount of time and finding an initial amount of time. Giant headache. But I know that my y is equal to mx plus b. That's a formula. So I'm going to use that to figure out what my b is, since I know what my m is, and I know a point on my actual line. I'm going to fill in my slope for my m. I'm going to plug in one of the points. You could plug in either one. You could plug in 622 if you want to. For this question, I'm picking 3, 10. And then I'm going to plug it into the equation. I plug in 3 for my x, I plug in 10 for my y, and now the only thing that I have left is b, so I just do some basic algebra to solve for b. 4 times 3 is 12. Subtract 12 from both sides. And I get b is equal to -2. And that's great. That's all I need. In order to build a slope-intercept equation, we needed 2 pieces of information, specifically the slope and the intercept. We have them, and we did all of this work. We're not going to get full credit on the test until we write the slope-intercept form, which is, if we do y equals mx plus b, plug in the 4 for our slope, plug in the -2 for our b, leaving us with the result. 4 is y is equal to 4x minus 2. So that's what I want as a final answer. And that last step isn't really doing a whole lot of math. Really, the math is done in step 1 and step 2, but you're going to lose all of your points if you don't actually answer the question, which is wanting that equation.
Okay, final 2 pieces of this section. Parallel and perpendicular lines. Just a heads up, my volume might be a little bit different right now because I'm recording on something else, so you might need to adjust it. Because it might be louder. Anywho, so parallel and perpendicular lines, we're going to build off of kind of the concepts that we've seen in the previous slides. We know the idea of slope, we know slope-intercept form now, and we're going to try and build equations with that information. So by definition, we would say 2 lines are parallel if, let's say we have something in slope-intercept form, they have the exact same slope. So these 2 lines, y equals 2x plus 3 and y equals 2x minus 7, will be different lines if we graph them, but they'll kind of never touch. They'll be almost like just 2 straight lines following the same track all the way along. Now 2 lines are considered perpendicular if they are intersecting each other, and at the intersection they have right angles, or they kind of form a T. And by definition, when we're dealing with equations, 2 lines are perpendicular if one is the negative reciprocal of the other. So in this example, if I have y is equal to 1/2 x plus 3, the slope on that first line is 1/2. Now the reciprocal of 1/2 is if I flip 1/2, I get 2 over 1, or just 2. And then I want to change the sign of that. So it becomes 2 over 1, puts a negative in front of it, and so that second equation, y equals -2x minus 7, would be perpendicular to the first one. Now to kind of see this in practice, let's say I want to find an equation of a line that's parallel to this equation and goes to the point 2, 3. Well, what's kind of interesting is that I'm only going to use some of the information from the first equation. So I know that my slope of that equation is -3. So when I try and find my new equation that goes through this different point, I'm going to start by forming y equals mx plus b and say, okay, I actually know what my m is. It's going to be -3. And then I kind of just disregard the rest of the equation. So I took my slope, I'm moving forward, and now I just take this y equals negative 3x plus b. I plug in my point 2 comma 3, 2 for my x, 3 for my y, and then I solve for b. Negative 3 times 2 is negative 6, add 6 to both sides, I get 9. And so my new equation is y is equal to negative 3x plus 9. And if I were to plot it, I would kind of have almost those like railroad tracks that never intersect with each other. Finally, perpendicular lines, very similar concept. We just have to do a little bit more work initially to figure out what our slope of our perpendicular line is going to be. So if I was asked to find a parallel line to this equation, I would just say, okay, my slope is negative 1/3. I'm going to go through the process I saw on my last slide by plugging in my 3 comma 4. But I'm not going to do that. This question, poorly phrased. This question should say I want to find a line perpendicular, so that's a typo. I want to find a line perpendicular to y is equal to negative 1/3 x plus 3. So to find my perpendicular slope, I find that negative reciprocal, or I change the sign of my reciprocal. So 1/3, if I flip it, becomes 3/1, and then since it was already negative, I'm going to change the sign to make it positive. So 1/3 flip is 3/1. It's originally negative, now it's positive. And so my new line will be y is equal to 3x plus b. It's worth mentioning that sometimes we don't have to be that like aware that if I have it over 1, it becomes in whole number. Like sometimes it's just a fraction of 2/3, and then I can take the reciprocal and I'm good to go. But it's nice to kind of see these examples where, okay, it looks like they're actually not related, but 1/3 flipped is 3/1, so I get the whole number. Okay, and then once I get past that first step, I just go ahead and plug in and solve for b again. So plug in 3 for my x, plug in 4 for my y. Negative 3 times 3 is negative 9, add 9 to both sides, so I get my y-intercept is 13, and so y is equal to 3x plus 13. Now, if you're having a couple of issues with seeing this kind of reciprocal thing, I recommend looking that up. Just like look at maybe Purple Math or something and see what a reciprocal is and see how to find a perpendicular line. And that goes for pretty much anything in this course. There's tons of resources online, so if you're not getting it the first time through with my videos, I won't feel offended. There's a lot of good resources out there, and feel free to use them.